Paleoclimate. Paleoclimate. Everybody say paleoclimate. Hey, what's paleo mean? Old. The study of paleontology is the study of old, like, things, old, like dead things. And climate, of course, we've learned about what a climate was in our last podcast. So what was the Earth like climatically, is that a word, from a perspective of the climate many years ago? I mean, we know what it's like today. We give records back about, like, really 100 years, really, with instruments. How do we know what the climate, like, a long time ago? That's the stuff of paleoclimatology, which is what we're going to study today. So, all right, hey, let's see what's going to do. What is a paleoclimate? Or is the climatic conditions in the geological past reconstructed from a direct or indirect data source? So this is basically old climates. We're trying to figure out what the climate was like in the past, which may lead us ultimately in a later podcast to what would the climate be like in the future. All right, so how do we know what the climate was like in the past? There's a problem. And here's the problem. We have about 100 years of what we call instrumental data. That means we've been measuring the temperature of the world using pretty accurate thermometers and, wind devices and all kinds of, weather-related devices. We've only got about 100 years. Now we've got people talking about, how cold it was and the amount of snow. And so there's some of that kind of stuff that goes back, in historical record, back 500 years and 8,000 years. But we really don't have any really good data that goes back more than 100 years. So then what was the climate like thousands of years ago? Well, scientists have come up with what they call the climate proxy. The proxy? You've got the proxy? The proxy is any feature or set of data that helps a predictable relationship to climatic factors and can be used indirectly to measure those factors. I said that funny. But the point I want you to understand here is that if there's something that is like a consistent pattern that we can find in the world today, and it checks with these 100 years, then maybe we can extrapolate, there's a big word, extrapolate, to kind of push it back and say, what was it like 500 years, 1,000 years, 400,000 years ago, etc. All right, the climate proxies are the following. There are more than these, but this is a pretty good smattering. What we're going to look at today is kind of the outline for the podcast. We're going to look at tree rings. I love tree rings. Ice cores. Fossil pollen. I have never known about fossil pollen until I studied to make this podcast. It's just like the coolest thing. All right, you'll find out in a bit. And deep sea sediments. Okay, so those are the 4 things we're going to talk about. Tree rings. All right. Now, most of you understand that in a tree, every year it produces a ring. Where the oldest ring of a tree is the one on the outside. The newest one is the one on the outside. So this would be present day. And the center core would be the age of the tree, when the tree was born. All right, so this is, if this tree I have is like 4 years old, kind of a baby tree. So year 1, 2, 3, and then the 4th year right there, right? Okay, so, but just because we know it grows every year, how wide the band is, if it's really narrow, that tells you something about the climate at that time. And if it's really fat, it's going to grow a lot in a particular year. So those tree rings give us amazing data. And then we check. So what we do is we take a look at, let's say we know in 1900 and, we have some data, 78, it was a very, very dry year in a particular part of the world. Then what you'll find is that the tree rings all around that area are going to be very narrow because the tree's not going to grow very much in the year 1978. But let's say that in 1982 or something like that, we know it's a very wet year, and so there's a big gap between tree rings during the 1982 year. So we can extrapolate, particularly the amount of moisture there. But now, but the interesting thing is, of course, is it checks with our instrumental data that we have for 100 years. So, of course, trees, the cool thing about trees is they're older than 100 years old, many of them, and then we can extrapolate back further, and it's pretty